LCARA Ham Radio presents a Time Machine Tuesday vintage video release.
Welcome to Lake Cumberland Amateur Radio Association. You can find us at LCARA.net, on Facebook, on YouTube, and on Instagram. If you're enjoying the videos we're producing here at LCARA, please help our club out by hitting that subscribe button. Also, give us some feedback on our videos. Click the like button, share with anybody who may find it interesting, and be sure to hit the bell icon to make sure you get notified of the next video release. All right, folks, hello, this is Chris, KY4CKP, and this week's On the Bench is how to make a simple ladder line or window line type roll-up Slim Jim antenna. And the one I'm going to be making is for 1.25 meter operation, since I have some radios that can do that. It's a pretty similar process if you were going to do 2 meters or 70 centimeters. Now, to do a combined 2 meter and 70 centimeters antenna, there's a little different additional process you have to do there, but there's plenty of instructions on how to do these kinds of antennas and projects, and I just kind of wanted to show my take on it. Now, one of the tools I used, as you can see here on the screen, I put up a web address. There's a calculator that you can put in the kind of antenna you want to build, and it will give you the calculations for all the areas you're going to need to measure for the project. So you can see that on the screen, and we'll take a look at that and come right back. All right, folks, a couple of tools we're going to use for this project is some window line, which is a thin, lightweight, dual conductor type line, some RG174, nice, thin, lightweight cable, some SMA connectors, at least that's what I'm going to use for typically using with my handy talkies, and the soldering iron, wire stripper, and crimpers if you've got them, and pre-existing, I've got a pre-existing antenna I'm going to use sort of as my model, the first one I made. And then, of course, the directions we printed from the website we saw earlier. So we're going to need just a few tools there. You'll see them kind of on the table. The other thing I want to point out is be sure and use the marine grade heat shrink tubing that's glue lined. Really helps projects like this to not only stay together, but helps give them a degree of weather resistance, if not weatherproofness. So what we're going to do, folks, is we're going to go off that sheet that we printed up. We're going to start making our cuts on the window line. I used to call it, it's the old TV, kind of TV antenna stuff you used to have back in the 70s and 80s. We're going to start making our cuts following the sheet. And one of the first things is to pick an end and cut back in the center part of this, leaving the copper so that we can bridge this connection. So the very top of it, if you will, we're going to be bridging that connection with some solder. So here in the next set of still pictures, you can see that we've cut back maybe a quarter of an inch, maybe a little bit more of a quarter of an inch between the two copper leads. We're just going to cut that away. We're going to strip the copper ends, just fold them over, basically 90 degrees, and we're just going to solder and bridge that across. So that'll be sort of the top of the antenna. We're going to create that bridge, solder it across, and then we'll put some heat shrink tubing on there just to finish that off, make it look a little bit nicer. All right, for this, folks, we're going to be making the a little cut, sort of the J-pole, if you will, kind of making the J-pole part of this. Again, the measurements are on the sheet that we printed out earlier and that we've seen on the screen a couple of times. You measure down, make your cut on this, and just follow the sheet, basically, and you're going to cut one piece of the copper. So here we are, we're ready to make our cut. We've got our heat shrink tubing in place. Again, we've marked it on one side. Make sure you're cutting the right side. The sheet has a diagram. Follow the diagram and the links for everything that you printed up. And you're just going to cut away one piece. Now, for all these cuts, I try to leave as much of the plastic behind as I can, just to, as you can see here, just to give us as much strength at the end of the project as we can get, along with the heat shrink tubing and that kind of thing. So we've cut away just that one piece of the copper, leaving the other one, kind of creating that J-pole effect. And then towards the bottom, we're going to, again, cut the bottom similar to the top, and we're going to create a section at the bottom, as we'll see here in a minute, where we're going to give ourselves some room to make adjustments to the antenna before we solder the RG174 onto it permanently. You want to check the SWR, make some adjustments, as we'll see, and then finish off that bottom part. So that'll be the final, basically the final section, and then putting on the SMA connector on the RG174. So here we've made this little cut, we've put on the heat shrink, we've melted it down, and so this little section, this little cut is good to go, and we're ready to move down towards the bottom. Now down here towards this bottom section, this is where we want to be a little bit careful, take a little bit of time, certainly. Again, of course, following all the measurements. But you want to cut out a gap. Now we want to leave the center of the plastic, really as much of that as you can, but we want to cut out and expose the two pieces of copper on the edges and tin those up a little bit to give them some strength. But you're going to want to create this little range here so that when you're attaching the RG174, you can actually adjust the SWR as you're testing it to get the best SWR you can for this antenna. And we'll see in the final testing section that I was able to reduce the initial SWR by just playing with the range of where I put the final solder there in that section. And then we'll cover everything up with some nice glue-lined heat shrink there at the end to neaten it up and again give it a bit of weatherproofness. Alright, and here getting towards the end of the project, this is the other end of the RG174. We're going to trim this out. We want to separate the outer shell from the inner core so that we can solder onto the gap that we just made in the twin lead or the window line. So keep those nice and separate so we don't have any shorts or anything. You'll again, initially attach those so you can test your SWR up and down that little gap you made. Find your best spot. Then you'll put it in place with some solder. Here you can see we've twitched them to make each section nice and neat. Then you just put it on there with some solder and then cover everything up with some heat shrink. Then you're ready to do your final testing with your SWR meter and you should be good to go. So here we did that. We've put on the SMA connector here at the end. There's different kits and they attach slightly differently, so you'll just have to follow the directions for whatever style that you purchased. It's kind of like a SO239 and some of those things. There's some different ways of attaching, but we've attached that. Here you can see we had attached in that gap that we created when we were testing the SWR earlier, and pretty much finished up the project. It really doesn't take that long. It takes a little bit of time maybe on the first one. And this one took me a little bit of time because I was filming and stopping and taking still pictures and all the rest. But it's a nice little project on the bench. It's not too difficult. The materials are not too expensive, and we can have a lot of fun with this. All right, we're in the final section here, folks, and I just captured some still images and a little bit of the video footage where I attach the Nano VNA and did some quick testing for the 1.25 meter over the spectrum, and it wasn't bad. You know, the initial spot I found on the wires wasn't too bad. You can see here 1.54 at the 225 part of the band, but I made some adjustments to it, as you'll see in the next picture, and got it a little bit better. So, excuse me, after we had adjusted this, the worst part of this band was 1.43, and it was a little bit better on the lower parts of the band. So again, that's why you want to cut that little gap and just take a minute, play with that a little bit. See, you know, just find the best spot that you can. And if you really wanted to spend time tweaking on an antenna like this, you could probably get things down to 1:1 or 1.1. But these are some pretty decent numbers here without obsessing too much about every little cut and every little measurement. So should be a good functioning antenna for me. I'm going to put it in a couple of go boxes I'm putting together. And that's pretty much it, folks. It really wasn't too difficult. The very final part of this was down by that connector. Once we had tacked it on to where the gap had been, I just double heat shrinked it. I put one size heat shrink on there and then the next size up, just to give it a good level of kind of protection and sealing, and again to help make it nice and strong. So that pretty much wraps it up for this project, folks. This is Chris, KY4CKP. Don't be afraid to get on the bench. Don't be afraid to try some of these things. And it's okay to fail. It's okay to make mistakes and do things a couple of times. It's a learning process, and it's a big part of what the hobby can be about if you like to do it yourself and be a maker. So get out there and try a few of these projects, and there's all kinds of other ones you could look into as well. We'll be doing more in the next year. But this is Chris, KY4CKP for Lake Cumberland Amateur Radio Association 73.